Hi, in this session we will discuss the application of probability and how concepts of permutation combination also helps in solving the questions based on probability. Let us look at the first question. Two squares are chosen from a chessboard randomly. Find the probability that they have side in common. Now, as we all know that in a chessboard the dimension is 8 by 8. That means you have 8 squares horizontally and 8 squares vertically. In all we have 64 squares. Now if I look at the application of permutation combination over here, I know I am selecting 2 squares randomly. That means the total possible selection will be 64C2. And my favorable cases, how many of them will be my favorable cases? I want the sides to be common. If I simply observe, I need not get into a permutation combination here, but if I simply observe, I will get 7 pairs in one horizontal line. So similarly, if I keep on counting all the horizontal lines, I will get 7 into 8, 56 such pairs in horizontal lines only. But I have vertical lines as well. So if I try to find out these such pairs in vertical lines, again because there are 8 squares in vertical lines, I will have another 7 pairs in each vertical line. So again 7 into 8, 56 pairs of squares which will satisfy our condition. So in all 56 plus 56, 112 squares satisfying this condition. So if I try to find out the probability now, probability will be 112 divided by 64C2. We need not get into exact calculation of this value because here when we look at most of the options will be in the form of C2 or P2. So here our final answer will be 112 upon 64C2. Let us look at another interesting question wherein we will see the application of probability, to be specific conditional probability. If we have a situation where a patient visiting a dentist will get his tooth extracted will be say 0.06 and a patient getting his cavities filled is say 0.2, and we are also given that probability wherein a patient will get both these things done is 0.03. Find the probability that a random patient visiting the dentist will have either a tooth extracted or cavities filled but not both. So here we have a condition. So if I look at the first case, a patient getting his tooth extracted, what is the probability? 0.06, and a patient getting both tooth extracted as well as cavity done is 0.03. So if I try to find out the probability of patient just getting a tooth extracted and not getting a cavity done will be 0.03. Similarly, a patient getting cavity done is 0.2 and patient getting cavity done as well as getting tooth extracted is 0.03. So if we try to find out the probability of patient having only cavity done and not getting tooth extracted will be 0.17. Hence, if I club both the cases, I will get 0.03 plus 0.17. So overall probability will be 0.2. And the most challenging question in probability is the concept of theorem of repeated trials. Now say the probability of a bulb being defective is 1 out of 5. Now the question asked is there are 6 random bulbs and we are supposed to identify the probability of not more than 1 defective pieces out of that 6 pieces of bulbs. So if we look at the question is slightly tricky. The question is not more than 1. That means I can have 0 defective or I can have 1 defective. Now if I try to find out the cases, 0 defective, that means all the 6 bulbs should be non-defective. That means first bulb being non-defective, what is the probability? 4 by 5. So similarly, all the 6 bulbs being not defective will be 4 by 5 raised to 6. Now second case, I want 1 defective and 5 non-defective bulbs. So if I want 1 defective will be any one of the 6. Hence my cases will be 6 times, that is 6C1. I can have any one of the bulb which can be defective. So 6C1, 6 such cases multiplied by the probability of being defective. So one bulb being defective, the probability is 1 by 5 into rest of the 5 should not be defective and hence 0.8 or 4 by 5 raised to 5. So 6C1 into 1 by 5 raised to 1 into 4 by 5 raised to 5 is the probability of second case. And if I am supposed to add both the cases, I will get the common value 4 by 5 raised to 5 as common. So 4 by 5 raised to 5 common, 4 by 5 left from the first case added to 6C1 into 1 by 5 in the second case, that is 6 by 5. That is 2. So 4 by 5 raised to 5 into 2 is the final answer. I am sure this type of question is very likely to be asked in CAT, and hence I suggest everybody to focus and practice more such questions. Thank you.